think we're inside a human being. Hey, computer, where are we?
You're right. We have just broken through the skin. This is what happened as we came in.
We made that hole? Hey, what else can we do with this machine?
We can do quite a lot with my toolbox.
Oh, I get it. This here, let's see, energy tools. Alright, let's have an explosion.
Hey, I don't want to explode. But here's something to try. This might give us room to move and get us a better view.
Oh no, we're shrinking. We must be microscopic by now.
Let's turn around and see where we came in. What's that following us?
Wow, they're really neat. Are they crystals or what?
I can analyze it with my scanner. See? Like this. Scan complete. Those are viruses. They have a cord of genetic material wrapped in a protective protein coat.
Stop that! Now those I do recognize. They're bacteria. Look at how fast they divide. What's that?
The molecules you see tell other host cells of the invasion and call them in to help.
Well, let's find those other cells.
We're coming to a dead end. Look at that cell coming through the wall.
Look, it knows where it's going. It's got those secretions to follow. Where are those cells coming from?
We can look and see. I'll send the BII after it.
An eye? Does it really see?
See for yourself.
Que bello! We made it on TV. Hi, Mom.
Okay, I've seen enough. Let's get back to the cell.
Ooh, this is like going the wrong way on the autostrada.
I've seen these before. They're red blood cells, so we must be in some sort of blood vessel.
Yes, but the red cells really obscure our view, so I'll filter them out. There. Now we only see the things we're interested in.
Much better. Here comes one of those white blood cells.
They must be attracted to the site of inflammation.
Oh, there it goes. It just squeezes itself through.
And here it is.
There's an interesting one over there.
That one?
No, him. Let's get closer. Will you look at that? It just makes a mouth when it needs one.
Look, it's coming for us. We've been eaten.
Where are we?
We haven't gone far, but now we're inside the cell. have a tougher coat than the virus.
Good thing, too. It's really going to pieces.
Great! I love to see that virus being chewed up.
What's it gonna do with the bits of virus? It looks like it's going to keep them on that
Molecule. That's the way the cell remembers what it has eaten. It uses those molecules as holders for peptides, short bits of protein. Now you see that it has lots of holders, so it can keep lots of different peptides.
It can't possibly keep everything it swallows.
Look, a hole. It's spitting us out. But the peptide holders are going onto the cell surface.
The computer's still analyzing.
Yes, the peptides on these surface molecules are all from proteins that have been digested inside the cell.
There are hundreds of them.
Wait, just a minute. There's still heaps of virus around. Where's it all coming from?
We'll send the eye to find out.
Is that really bits of virus that we see there? And I just don't understand.
Let's put it down on paper. Virus. Cell eats virus. Inside the cell, enzymes cut the virus up. The pieces are stuck onto, let's say, calling cards. When the cards appear on the surface, just a glance tells an observer exactly what that cell had for lunch.
What's the writing on the card? Major
histocompatibility complex, MHC for short. MHC class 2 in this case.
That's complex.
But why is the cell's lunch important?
Let's go and see.
Another blood vessel, right?
No, it's the lymph system, a different network. Here's the network, and here's where we are.
Yes, and our cell is already gone.
So this is what the eye is seeing? This is really neat.
Yeah, but what does the virus do when it gets inside the cell?
I'll send the eye into the cell. First of all, the virus takes off its coat. Then it starts to copy its genetic material. Next, it goes to the nucleus and takes over the cell's machinery to make new virus.
This is real action. Let's go and look ourselves.
What about the cell with the lunch?
We can always find it. It has a calling card.
Here we are already.
Analysis of cell surface in progress.
Funny, there are peptide holders here too.
Get it right. They're MHC molecules.
That's MHC class 1. It's present on all cells. The peptides come from whatever proteins are produced inside the cell. If a virus has infected the cell, peptides from the proteins of the virus are presented on class 1. These coins represent proteins being made inside the cell. Bits of the proteins go on to calling cards. With MHC class 2, it was bits of what had been eaten.
into our cell. It looks like new viruses are made. Wow, so many of them.
Impressive. All that from one virus going into one cell.
How does it do that?
Here's the scheme. The virus uses the machines of the cell to reproduce. New viruses leave the cell. The cell eventually dies. The new viruses go on to infect more cells. That's the life cycle of a virus. It can reproduce very quickly.
Mamma mia! It's deadly! I knew! We should have killed them!
If that's what happens to one cell, I wonder what the future's like for the whole organ.
I'm afraid it doesn't look good. If nothing interferes with the virus's life cycle, it can destroy the whole organ. And that's why we have an immune system.
Let's see how that immune system works. I think we need to know what those calling cards really do. Let's take the BII and look what happens to the cell with the lunch.